So how's everyone doing today? Good? Everyone's awake? Everyone's excited to be here? Yeah? Everyone's ready for happy hour? All right. So today I'm going to be talking about 3D design and alternative delivery. Now, a lot of the presentation is 3D design centered, a lot of the benefits. Most of it can apply to design bid build, but we'll talk a little bit about how it can apply to design build or any other type of alternative delivery with a few examples. So, does anyone know what this is? Yeah? Is everyone excited about going back to using one of these? No? Good. All right, anyone know what this is? Yeah? Okay. So as we move through history and technology, anyone ever used one of these? Okay, I'm getting a gauge for, see how old everyone is. Okay, yeah, now computers are getting smaller. Technology is getting better. We have more power and more technology in smaller things. We can take all of that plus more and stick it on my treadmill. So this is my home office. I can do a lot of design out of my laptop on top of really old shelving on top of my treadmill. And I can also do it on the plane. So I wanted to illustrate that technology has moved incredibly fast in the last 30 years, in the last 50 years, even in the last 10 years. That we can take a lot of our design tools that we use every day, we take for granted, and pack it into a tiny little object. It's only going to get better or worse, depending on your stance. So we're going to give you about 10 seconds here. We're going to quiz you after this. I want you guys to take a look, and we're going to ask the question of what's different between the schematic intent on the top and the design change on the bottom. Everyone got a good picture? Go ahead and then text it in. All right, let's move on. So now this is a 3D model of both. We took the 3D model from the RIDS and the 3D model from the design intent, from the final design. We're going to give you, a little bit less time. Take a look at it. Don't share your answer until the next slide. Now I'm cheating a little bit because I can make different colors, and I have different perspective. But let's go ahead and see what do we got now. All right, yeah. We probably did both, but the biggest thing that I saw was B. So this is that same from the top view. We didn't need to see it from the top view. We can see it from the side view if we wanted to. But this is a design change that allowed TxDOT to save $500,000 in construction costs, if we're just talking about retaining walls and bridge. Now, for some of the examples that we're going to move forward with, that's really what we're going to be focusing on, just because we can focus on any number of construction costs, but to keep apples to apples. Now, 3D design is not 3D visualization. So to illustrate that, we're going to go through a little example of what the differences are. 3D design, we're going to take this model here, this plan view, this project out in Austin, or near Austin. This is our typical plan view that we're going to overlay on top of it. And this is how we normally start our design process. We start our alignments and our edges of pavements. Now we're going to be really concerned about its environment. We're going to wonder how we're going to take a look at, or how we're going to handle the trees that Austin really likes. But this could be driveways, this could be structures, this could be houses, property, this could be anything really. But typically what we've done is we'd run cross-sections. We'd create our typical section. This is our typical section. And then we'll write criteria files. Has anyone written criteria files? So it's a lot of programming. A lot of the guys back in the day would really get into this, and it would take a lot of debugging, especially if it didn't run right. Today, we have visual criteria. We have templates. It's a lot easier now. Today, we can use 3D design to draw our criteria. It draws it in an XML format, but it's pretty much kind of extruding it or dropping it every 10 feet or 100 feet or 5 feet. all so we can get down to our cross-sections. Now, for a typical design, we'll run cross-sections every 100 feet, or every 50 feet, every 25 feet. But we don't get to see every detail unless we purposely make every detail. We want to cut a section in between section 5 and 15, we have to purposely make a section there, or cut a section, just so we can get these cross-sections. Now, what 3D design is taking these cross-sections and putting them in three-dimensional space. And we're going to take away all the grid. Okay. And we're going to put the roadway underneath it and the topo, everything around it, and we're going to multiply those cross-sections by 1,000,000 or 1,000. We're going to stitch them together so that we can see everything that happens in between the cross-sections based off of our visual criteria, our rules that we had told it, made it work that way. Yeah. So, there are some truths to be had here. There's no more Geopack SS2 development, so there are no more criteria. This is the typical design software that we'll use to create these cross-sections. Criteria is moving away from the current products. These current products are centered around these three-dimensional models, or these templates, these visual criteria. It's being embraced by DOTs around the country, some faster than others. TxDOT is pretty much in the middle of the road, or a little bit more advanced. TxDOT will shift towards a 3D model-centric deliverable in the coming years. Now, that could be 20 years from now, or that could be 10 years from now, but eventually, as the industry moves forward with technology, 3D design modeling, 3D modeling itself, not visualization, 3D modeling for construction will be much more important. In order for that to happen, we need to change some contract language, policies, procedures. It'll be further refined to allow for this, and some states are moving forward with this, or they're making plans to do this. And FHWA, if you're interested about more 3D design modeling and how it applies to construction, FHWA has included a whole segment of 3D design modeling for construction in their Everyday Counts program. So this is kind of a quick question here, but if I'm drawing something in my design software, AutoCAD MicroStation, is a 3,000-foot arc really drawn as a 3,000-foot arc? Or do I go in and I calculate, everything and draw everything and scale it? You guys are jerks. So why are we doing this? Okay, we want to convey the design intent. And as you saw in the previous example with the two projects, the schematic and the design, we can push out a lot more information in a more digestible format. These are design models, so this is exactly how it's going to look like. This isn't an artist's interpretation. We want to build relationships to build confidence in the design. So we want to build relationships between all the different elements in the model. The horizontal geometry, the vertical geometry, all of its cross-sections, they don't exist as separate entities, they're all tied together. So what exactly are we trying to model? Traditionally, when we think about 3D modeling, it's 3D visualization. With 3D visualization, it's pretty much just a pretty picture. It's an engineer that gets with a graphic designer and kind of tries to make it look pretty, make it look good. Today, we're moving towards design modeling. So we're taking those 3D models that we just showed you, and we're using it to calculate things. We're using it to help us make better informed decisions. We're going to run through this over and over again. We're using better information to make better informed decisions. Then we can go ahead and start using this design model, move it forward into simulation models. So we're going to get into 4D and 5D. Now 4D is taking the 3D model and applying it to a construction schedule or any type of schedule. 5D is applying those different parts of that model and adding cost to individual pieces. So you can see when you're going to be taking out money at what time, at what month during any construction phase. And then construction modeling is taking that construction model. As they're building as they're building it out in the field, you can update the design model and create this construction model that will eventually fulfill itself as an as-built, a 3D as-built. Now, we all know that when we go and create projects, when we go and design projects, the farther down the production line you go, the more expensive it is to change something, change a design feature. As you see here in this graphic, the requirements, analysis and design, coding, testing in the large, so coding and then fixing and then tweaking. If you go back at the end of the project and say you want to change this ramp location, it's a lot of effort. Well, we want to make that a little bit easier. We can create design rules so that if we were to change one part of the design, we can see its effects throughout the rest of the design. And some are easier than others, but we'll go through some examples. And we're building relationships within the software to help us do our job and automate some changes Because really, at the end of the day, we just want to make sure we automate make things faster. So this is a quick example. This is pretty simple if you've ever worked with this design software, but we have a little driveway or a little intersection here, and all I wanted to do is change its location. Now, if I'm already farther down the design line, I'm going to change my alignment, delete all my edges of pavement, rerun my cross-sections, rerun my model, make sure everything is good. Here, I can just click and drag parts of the alignment. I can move the alignment, and it will adjust my slopes based off the visual criteria that I have. If I wanted to go in and change the returns, I can go in there and change the returns. I can go move the alignment again. I can slide it back and forth. This is incredibly helpful if you're trying to do some preliminary planning or if you're coming up with alternative technical concepts. We'll get into that in a little bit. And you can click on pieces of it. Now, these are all the relationships that I've built, and this is really simple. You can get a lot more complicated than this. Another thing we can do is create basic geometry checks for us. We can create design standards that help warn us, that tell us, okay, my alignment is below my design minimum or my recommended minimum. It can warn us and help us do our design, help us check our design. So as we make changes to the design throughout multiple disciplines, if we're all in this 3D environment, we can now run clash detection. So we can see if our SUDA pipe that we use with Bentley SUDA and our open bridge model, if we're going to be conflicting with each other. And this has happened in the past where we've had a storm sewer plan go right through one of the piers. If we were to do an interdisciplinary review, maybe we would have caught it. We would have looked at all of the plans and gone back and forth and maybe have caught it, and sometimes we wouldn't. But if we're all in this 3D environment, anyone who opens up that model can see that there's obviously an issue. We need to get on the horn and fix it. We can also keep track of it. So this adds to the QA/QC documentation portion where we can have all these clashes and document it all and say that this is new, this is where it's at, this is a hard clash, this is a soft clash. We need to go fix something. Now we can go into vertical clearance options here. Vertical clearance options where I submit to the bridge guys my plan view, my profile, my cross slopes, my super elevation, and I want to check my vertical clearances. Well, traditionally we'd have to use this Excel spreadsheet or something similar and run all of our elements, all of our beams, our haunch, our deck, subtract it all, find the surface underneath, and check it out. Now we can find it really quickly. If we change our profile, if we change our super elevation, we can see immediately if we're going to run into these vertical clearance issues. It could be vertical, or it could be horizontal, but it allows us to see the entire environment all at once. And as you can see here, we can keep track of it, new, old, resolves. We can display the model in different formats and different views to help us serve our needs. Say I wanted to find out where I need riprap. I can change the model and make these slopes point out, hey, anything that's yellow or red, I'm going to need slope stability, or I'm going to need a retaining wall, I'm going to need riprap. It's giving me more information right off the bat without having to look at contours and in 2D and plan view and say, okay, you know, maybe I can adjust the profile a little bit and make a better design and save people a lot of money. If for whatever reason I wanted to see what the 500-year water surface elevation is without looking at contours, I can just place a little shape there and see whatever is underwater at 500 years, at the 500-year water surface elevation, whatever is going to be flooded is shown right there. Now we're going to go back to that example, and this is where we tie it into the contractor side, what we're really focused on, or the developer side. We can run quick component quantities on different options. So this is a quick live example of checking quantities. And here I ran quantities for the pavement structure. And now I'm going to double the pavement structure. Say someone comes back to me and says, I messed up. I want to make the top layer pavement double the size. I'm going to update the model. It's going to update portions of the ditch because I told the model to say I want my ditch to be a little bit, at minimum, a little bit lower than the bottom pavement. And you can see here that I ran the quantities, and it's double the amount of quantities. So that's that example here where we can run quick quantities, and we don't have to go in and calculate everything by hand or create shapes or measure everything. We can click on the option and find the quick quantities. Now, if you've ever had to run cross-sections with criteria, sometimes it would work and you'd have to go and debug it, and sometimes it wouldn't work at all. In open roads, this is a really quick way to run cross-sections. It cuts it like a cake. Once you have the model, you can cut a cross-section anywhere. As you see here, I can also look at my profile view, my dynamic cross-section view, my 3D view, my plan view all at the same time. So if I make changes to the profile, it'll update the model. It'll update the model, and it'll show me what I'm affecting in any other portion of the design. Am I putting people to sleep yet? So here it creates a quick cross-sections. You can set it up for whatever format you'd like, especially if you'd like to look at cross-sections. It doesn't even have to be full cross-sections. It could be partial cross-sections. You don't have to be done with the design. You can do part of the design and run it. And here I'm going to run earthwork, so I can run quick earthwork. Now there's a million ways to do the same thing. You can create models different ways, you can run earthwork different ways, you can calculate the quantities different ways. This is just one way of creating the earthwork. And this is end area method, which everyone loves. But we can run our cross-sections every 1 foot, and we can get a lot more accurate quantities if we needed to. Now this is another example that I put together in like 20 minutes. So I created an alignment and a quick profile to go over that previous example, and I wanted to create a loop ramp. It's not perfect, but if say I want to explore an ATC, I want to explore a different concept. You can see relatively quickly that I can go in and calculate quantities from this one option. So I have different quantities, I can zero them out, I can put cost to them, I can get the money, I can get the total estimated cost if I wanted to. Now let's say that I needed to go change my slope. My slope is too steep. If I go and change my profile, it's going to reprocess. See how it changed part of the design on the side, on the right? I'm going to run quantities again, and then I can compare what did my profile change affect as far as quantities. Now, there may be big differences because in my template, I created a bunch of rules that say if I'm going to go down from the edge of pavement, go down at a 6:1, and if it goes past my constraint lines, my right-of-way lines, I'm going to go down to a 6:1, 5:1, 4:1, 3:1, 2:1 retaining wall. Let's say I have plans for a building in that loop ramp that I didn't know about, but I found out last minute. Well, I want to adjust the design because I don't want my slope to go to the first floor office space. So I'm going to move my constraint lines. You can see that on the left here. I'm going to move my constraint lines, and it's going to calculate, it's going to make changes for me, and it's going to tell me how much retaining wall I need. So I'm removing the slope. I changed my constraints. It added some 2:1 riprap. Now these are all live demos. I'm not speeding anything up. I'm not making anything fast. But if you really wanted to explore wacky ideas or ideas that could potentially save millions of dollars, this is one way you can do it. Now let's say I didn't like that option and I wanted to explore a direct connector option. Again, this took about 20 minutes to do. I don't have enough time to show everyone, but here we can see we can calculate the quantities of that particular option. Now, how does this help me with alternative technical concepts? We can add to the process of evaluating ATCs by including these over-the-shoulder reviews or workshops so that we can have better confidence between the owner, between TxDOT and the developer. Between the contractor and the designer, we can go run through these options and show more detail with a lot more confidence rather than saying, hey, trust me, it works. Or rather than giving me a set of plans and give me a few days to study it. I mean, these guys have to review it, review a lot of ATCs all at once. So the easier you can make it for somebody else, the better time you're gonna have. So really, at the end of the day, you want to be able to assess and hopefully lower the risk using this technology. Now, I want to stress this doesn't take the place of design experience, but it better communicates the design. Now, over-the-shoulder reviews can help build real-time confidence. We can develop models that switch back and forth between different options. And we're going to save a lot of time instead of showing you the sections and giving you time to look at them. Now, this is another example where we have schematic RIDs, and we're wanting to reduce the cost of retaining wall and bridge. So see here, that one option that we got from the RIDs, we got the model from the RIDs. The retaining wall and bridge, $17 million. Someone came up with an idea of removing the whole main lane bridge and creating these elevated turnarounds. So as you see here, we reduced significantly the cost of retaining wall and bridge in this one particular option. However, through the design, through the modeling, through the reviews, we've determined that the slopes are too steep and it changes the functionality of the whole interchange. So this ATC was denied, or it didn't even move past the second option, because we were able to find out all its potential issues relatively quickly. Now, what does it take to get there? The training is really key, just like you had to train someone to learn how to do criteria. So anyone who had to go through that painful experience would understand what the effort is to learn new software. But it's a lot easier. So we can train a 3-month EIT, which we're doing right now, the basics of corridor modeling, and produce better cross-sections a lot faster than someone with intermediate criteria experience. Contractors can use this in conjunction with rovers and survey control networks out in the field. Now, with this technology, with open roads in this particular case, if anyone's still on SS3, the production of I-models was a little bit wonky. SS4 has really fixed a lot of that. If any contractor is using Trimble Business Center, Bentley I-models work very well with that. It gets you a lot more information than XSRs. So sometimes in today's scenario, we're building these 3D models, or we're designing these 3D models, and then we dumb it down to 2D and then have to give it back to the contractor to take the XSRs and put them back into 3D. That doesn't make any sense. So let's give them the I models. But that requires some legislature change in some of those. And how do we sign the model? Some DOTs around the country are figuring out different ways to sign this electronic document, to seal it. And one of the ways is through this iModel protection certificate location over here. Oh yeah, there we go. A potential workflow centered around a 3D model is provided 3D models, over-the-shoulder review, proceed to final design, feed AMG, create the 4D scheduling and optimization, create 5D cost analysis and optimization, and then develop asset management and operating and maintenance. I mean, that's one way we could do things, eventually. Now, other DOTs are putting together their 3D design models for construction. Utah has a few examples, SR20 and SR10. They've provided the contractor with plans as information only. Now, that's a little unsettling, but DOTs are moving forward with this type of plan. Either they're creating the support for it, or they're moving forward with legislature change. In this case, in Utah, they made some of these changes and ran 4D and 5D analysis on these two projects, these two pilot projects at a CMGC contract instead of a design build. But it could easily be, well, not easily, but more research is required to do that and for design build. 5Ds with the cost, we can have more QA/QC, and eventually, hopefully, go into asset management in our models. Now, we can get into a little bit of fun here with virtual reality and augmented reality, but we'll touch base on that in a little bit in 2 seconds. Now, these are excerpts from the Utah DOT IDC guidance document dated April 2017, where they were able to save as much as 50%, skipping the 2D design plans in some areas, 50% of time. And now we're thinking about some foremen out there in the construction guys. They had minimal training out there, and they started using the plans at the beginning of the project, 15 to 20% of the time. But as the project moved forward, they got used to using the 3D model. Now this is an example of scheduling, 4D modeling. Now that's a big example. This is a little bit more granular, so we can see that there. But that's not really, that's just the visualization, right? That's just a pretty video. I want to be able to move back and forth, and maybe I need to move this phase of construction to another phase to optimize the design. So as you can see here, I'm moving back and forth, or I'm going through the design process. I'm going to click and drag. And I'm going to get with the scheduler. What the scheduler does in their head, they can do out here. Virtual reality, you can create little markups. One day. The vertical design construction area, the traditional BIM, I think Autodesk has a proof of concept that showed someone that they can do a framing plan without any plans at all, just using this AR or VR, virtual reality, or augmented reality. They can make plans. So at the end of the day, we want to reduce risk by finding potential issues earlier, reduce time for alternative analysis exploration, quicker quantities, increase the confidence in design, convey the design intent faster, and it shows its considerations to the other design elements, and we can create a closer relationship between everyone involved. Any questions?
Questions?
After.
4:50, 5 o'clock.
Thanks.